Today is day 2 of looking at quadratics in word problem situations. So we'll do a few of these problems together, and the rest will be practice for you. And you'll have your test coming up soon. I think we have a team quiz, a project, and a review before the test. So again, we'll do a few of these together. Let's start with number 1. We have a rectangular lawn measuring 8 meters by 4 meters, and it's surrounded by a flower bed of uniform width. The combined area of the lawn and the flower bed is 165 meters squared. What is the width of the flower bed? Well, we can start by labeling our picture here, and if there's not a picture, it's usually helpful to draw one. So let me do this. So again, the rectangular lawn, the smaller portion here would be 8 meters by 4 meters, and it's surrounded by a flower bed of uniform width. So we're solving for a few missing lengths here. This length right here would be x. Let me make this look a little bit better. This length is x, and this length is x. So again, we have an x here, an x here. So here are the unknown lengths. So again, what is the width of the flower bed? So the flower bed, really here's what you want. We want the length of the flower bed times the width of the flower bed. And if you remember from geometry, area in a rectangle is length times width. So area equals length times width. And in this case, the length is, we have the 8 meters plus x on this side. I forgot to label this one. X on this side and x on this side. So the length is 8 plus 2x. The width, again, we know that the lawn is 4, but we have to add an x to each side. So 4 plus 2x. So in blue right here, that would represent the area of the flower bed. So let's multiply. You can FOIL or you can use a rectangle to multiply that out. I'll FOIL this. We have 32 plus 16x plus 8x plus 4x squared. So again, you can FOIL or use a rectangle to multiply this out. Either way, you should get the same answer. So if we combine like terms here, we'll get 32 plus 24x plus 4x squared. So we can see this is a quadratic with the x squared here. It's not in general form yet. We do know that the area of the flower bed is 165 meters. So let's set that equal to 165. All right, our goal here is to solve for x. And if it's quadratic, and if we set it equal to 0, we know that there's many methods we could use to solve. So let's do that. Let's put it into standard form, but also get 0 on one side. So we'll subtract 165 from each side. So we will get 0 equals, and I'm going to put in standard form, so we have the 4x squared plus the 24x, and then 32 minus 165 is negative 133. So again, at this point, you have a few different options. You could try to factor this with a box and circle. Let's put it into quadratic formula if you don't like to guess if it's going to work in the box and circle or not. So you would identify A, B, and C. So here A is 4, B is 24, and C is negative 133. We have x equals opposite B plus or minus the square root of b squared minus 4ac all over 2a. And again, I would want you to calculate your three musketeers here, these numbers right here. So when we do that, we get x equals opposite 24, so negative 24 plus or minus the square root of 2,704 all over 4 times 2 is 8. And so when you put this in your calculator, remember do the top part first, negative 24 plus the square root of 2704, hit enter, divide by 8. And if you do the plus, you will get 3.5. And if you do negative 24 minus the square root of 2704, hit enter, divide by 8, you get negative 9.5. So here x, we have two answers. But for this one, if we're looking at the width and length of the flower bed, the positive number is the only one that makes sense. So here it is 3.5. So x is 3.5, but the actual length and width, so if you remember the length, is this 8 plus 2x. So you would plug in 8 plus 2 times 3.5, and that length, the length would be 15 meters. And then do the same thing for the width. So the width would be 4 plus 2x. So 4 plus 2 times 3.5. So that's 7 plus 4 is 11 meters. So your flower bed is 11 meters by 15 meters. So there's an application of using quadratic formula to solve for length and width. Okay, let's try setting up one more, and then we'll actually solve one more before I let you guys do the rest. Let's do number 2. Mr. Jackson had a rectangular shaped garden where the length was 2 less than the width. If the area of the garden was 420 square feet, find the dimensions of the garden. So you might want to underline your important information here. So the length was 2 less than twice the width, and the area was 420 square feet. All right, so let's say that this was the width. I'll call the width x, and here's the length right here, and the length is 2 less than twice the width. So if we do twice the width, that's 2x, and it's 2 less than that. And again, remember the formula for area. Area is base times height, or length times width. So the area is x times 2x minus 2. And we know that the area is 420. And let's distribute this. We'll get 2x squared minus 2x. Again, if it's a quadratic, and if you want to use quadratic formula to solve, you can subtract 420 to get 0 on both sides. So the equation that we're looking at is 0 equals 2x squared minus 2x minus 420. Now you could factor out the greatest common factor of 2 and try box and circle, but again, if you don't like doing that, you can just jump right into quadratic formula. So let's do that. We have a is 2, b is negative 2, c is negative 420. So you can plug in, and I'll let you solve that for x. So you're going to solve that for x by plugging in a quadratic formula. And so the answer, you'll get a positive and a negative answer. This one, again, the positive answer will be x. So plug into quadratic formula and solve. And then to get the length, you'll have to plug in and do 2 times your length minus 2. Okay, so I'll give you a little time, try quadratic formula, and then I'll put the answer up. Okay, so here would be the answer. The positive answer, you would get x equals 30 doing quadratic formula. So right here, the width is 30, and then the length is 2 times 30, which is 60, minus 2, and so that would give you a length of 58, and this is in feet. Okay. We are going to look at one more problem, and then you'll have a few to try on your own. Let's look at number 3. So let's say we have Anna. She tosses a coin off a bridge into the stream below. The distance in feet of the coin, I made a typo, the distance in feet of the coin above the water is modeled by this equation, negative 16x squared plus 96x plus 112, where x represents time in seconds. You can see that this would be a parabola that is an upside down u because of the negative 16. And we want to figure out 2 things. What is the greatest height of the coin? How much time will it take for the coin to hit the water? Okay, so if I sketch this situation, all right, so here it is. So we have the distance and x is time. So here's time. Here's the distance above the water, so height, I should say, but distance or height. And if we were to sketch this, you're throwing it off a bridge. We want to figure out when does it hit the water. You can see that if we graph this, that one answer will be negative. So we're going to look at the positive. So the greatest height of the coin is the vertex right here. And we've talked about shortcuts for finding the vertex, and one of them is to find the time where this would be negative b over 2a to find the x-coordinate of the vertex. All right, so let's take a look at b would be 96, so we have negative 96 over 2a, 2 times negative 16. That's negative 96 over negative 32, and that would be 3. So at 3 seconds, it would reach its highest point. So that's so that would be the time, but it asks what is actually the greatest height of the coin. So we want to plug in and actually solve for y. So let's do that. So we have y equals negative 16, and we know it's at 3 seconds, so 3 squared plus 96 times 3 plus 112. So you can type that in your calculator, use parentheses. And the greatest height is at 256 feet. So here the vertex is 3256, where 3 stands for 2 seconds and 256 stands for the feet, the height above the water. How much time will it take for the coin to hit the water? So now we're looking for one of the zeros, or the x-intercepts of the graph. So again, there's many ways that you can use to solve, and I would just plug into quadratic formula so we wouldn't have to deal with completing the square or box and circle. Okay, so right here, quadratic formula. I guess I could have left that up there. So you have a equals negative 16. B equals 96, and C equals 112, so that's from the equation above. You have your formula x equals opposite b, so negative 96 plus or minus the square root of b squared minus 4ac all over 2a. So I would want to see this work on your assignment, also on your test. And I would want to see this part, negative 96 plus or minus the square root of 16,384. 16,384 all over negative 32. And this is actually a perfect square. It's negative 96 plus or minus 128 over negative 32. You'll get 2 answers if you solve this. If you plug this in your calculator, and you have x equals negative 1, x equals 7. So again, if we go back to our graph, here's that negative 1, but we're not looking for that one. We're looking for when does it hit the water over here, and that would be 7 seconds. So now you have a few more problems to try on your own. Maybe we'll set up number 4, 5 should be okay, 6 should be fine, 7 should be fine, and then a few review problems. So let's set up number 4 together, and then you'll try the rest on your own. So number 4, a square and a rectangle had the same area. The length of the rectangle, let's do this. The length of the rectangle is 5 inches more than twice the length of the side of the square. The width of the rectangle is 6 inches less than the side of the square. Find the length of the side of the square. Okay, so we're going to just label variables here. I'm just going to call the sides of my square x. A square has 2, length and width will be the same in the square. So that says the length of the rectangle is 5 inches more than twice the length of the side of the square. All right, so 5 inches more than twice the length of the side of the square would be 2x plus 5. The width of the rectangle is 6 inches less than the side of the square. Okay, and the areas are the same. So the area of a square is base times height, or x squared. And that area is the same as this area, 2x plus 5 times x minus 6. So for this one, you would use a rectangle or foil to multiply out 2x plus 5 times x minus 6. So you get x squared equals, and if we multiply that out, we will get 2x squared minus 12x plus 5x minus 30. Combine like terms, and also subtract an x squared from each side because we want 0 on one side. So we have 0 equals x squared, combine negative 12x plus 5x would be negative 7x minus 30. Okay, and so again for this one you could use a box and circle, or you could use quadratic formula to solve. So I'll let you decide, and again solve for x. I'll give you a minute or two, and then I will put up the answer. All right, this one I would probably use a box and circle, so I'll show that method. So for a box and circle, you'd put the x squared minus 7x minus 30. And you would think, all right, what two numbers multiply to negative 30 x squared that add to negative 7x? And that would be negative 10x and 3x. So here it is, negative 10x, 3x. Get the outside x minus 10, x minus 3, plus 3. So here it is, 0 equals x minus 10, x plus 3. And if you use zero product property to solve, what would make this factor 0? Negative 3. But that can't be the side of a square. And this one, what would make x minus 10 equal to 0? That would be 10. And so here's your answer. The sides of the square is a 10 by 10 square. The rectangle, 10 minus 6 is 4 inches. I should put my units. And this one would be 10, 2 times 10, 20 plus 5 or 25 inches. They both have an area of 100. And then it works for all the rest of the constraints as well. Okay, so try the rest for review, and if you have questions, we will go over them in class.